A $55 rubber oil line cracks on a Toyota Camry somewhere between 40,000 and 70,000 miles. No warning light, no smoke, just a faint smell most owners ignore. Weeks later, the repair bill hits $4,300. That's one of 7 hidden failures lurking inside some of the most trusted Japanese engines ever built. And nearly all of them start with a symptom you would never think twice about. A faint oil smell inside the cabin is easy to dismiss, but for thousands of Camry owners, that's where disaster starts. Under the hood, a short length of rubber oil line runs from the engine's pump to the filter housing. Over time, sometimes as early as 40,000 miles, the rubber hardens, cracks, and starts to seep oil. Heat from the exhaust manifold accelerates the breakdown, especially in city traffic where stop-and-go driving keeps temperatures high. Most owners never notice anything more than a slight odor, maybe a tiny oil spot under the car. But the real danger is hidden. Oil dripping onto hot metal can ignite, or worse, starve the engine of lubrication without warning. A quick ultraviolet dye test, costing around $45, can reveal even the smallest leak in seconds. Technicians recommend tracing along the hose with an ultraviolet lamp, looking for glowing streaks that signal trouble. If a crack is found, waiting even a week can turn a hose replacement that costs $55 into an engine overhaul that costs $4,300. Some owners try aftermarket silicone hoses to save money, but shop data shows higher rupture rates in hot climates. The safest fix is an OEM hose and double clamp assembly, installed by a shop that understands the stress these lines endure. Every extra mile on a brittle hose is a gamble, one that too many owners lose. The lesson: when a technician suggests a dye test for an oil smell, don't put it off. Catching a cracked line early keeps a minor repair from becoming a financial nightmare. A sudden spike on the temperature gauge, then nothing for weeks. That is how the valley coolant leak begins. On engines like the Subaru EJ25, a composite gasket buried deep in the block slowly breaks down with age and heat. As early as 60,000 miles, this hidden seam allows coolant to creep into the engine valley, where it quietly pools out of sight. The first sign might be a low coolant warning that comes and goes, or just a faint drop in the reservoir that is easy to blame on normal evaporation. But inside the engine, every drop of leaked coolant mixes with oil, turning it milky and corrosive. Left unchecked, this contamination eats away at bearings and cylinder walls. Shops have learned to use a borescope, threading a camera into the valley to catch the telltale film of coolant before disaster strikes. One technician's footage shows a silvery sheen coating the block, revealing the leak long before the head gasket fails. Catching the problem early means a gasket and labor bill under $1,200. Ignore it, and the next step is a warped head or a seized engine. Repairs can top $4,000. The difference comes down to recognizing those sporadic temperature spikes and insisting on a borescope inspection when the usual fixes do not add up. A careful look inside saves thousands and keeps a subtle leak from turning into a catastrophic rebuild. A turbocharged engine lives or dies by oil flow, and sometimes the smallest part can take it all down. Deep inside the oil feed line, a mesh screen just 0.2 of a millimeter wide stands guard, meant to keep carbon and debris out of the turbo bearings. Over time, heat and dirty oil cause carbon to bake onto the screen, shrinking the openings and choking off flow. The first sign is subtle, a faint turbo whine or a sluggish boost that most drivers blame on a dirty sensor. But as the blockage grows, oil pressure drops and the turbo shaft spins dry at tens of thousands of RPM. Bearings seize, and the whine turns into a grinding shriek, sometimes with no warning at all. A technician's spin test can catch early trouble. Removing the oil line and spinning the turbo by hand reveals resistance or a gritty feel if the bearings are starved. Shops recommend inspecting and cleaning the turbo oil screen every 30,000 miles, especially on models like the Mitsubishi Lancer Evolution and the Subaru WRX. It is a quick job, less than an hour, but neglect can turn a $20 screen into a $3,000 turbo replacement. Sludge buildup does not just slow the turbo, it can destroy it in a single drive. The lesson is simple: do not wait for the whine. Build cleaning the oil screen into your regular service schedule and use high-quality oil to minimize carbon. A little prevention keeps the boost strong and your wallet safe. A flicker from the oil pressure light at idle is the only warning most drivers ever get, but what happens next can total an engine in minutes. On models like the Nissan Maxima and Toyota Corolla, a brittle internal gasket tucked deep behind the rear main seal or oil pump can develop a hairline crack. Oil starts to bypass the pump, dropping system pressure to dangerous levels. Many owners assume it is just a faulty sensor or low oil topping off the reservoir and driving on, but a technician with a mechanical oil pressure gauge can reveal the truth. If pressure dips below 10 pounds per square inch at idle, especially when the engine is warm, the bearings are already at risk. Gasket material in these engines is known to harden and shrink after 70 to 100,000 miles, especially with frequent stop-and-go driving. The fix itself is simple: a $45 original equipment manufacturer gasket and a couple hours of labor. But if the warning is ignored, the oil-starved bearings can seize, turning a minor repair into a full rebuild costing over $4,000. Shop records show that aftermarket gaskets, even those labeled high temperature, fail early in about 1 in 10 cases. For owners, the lesson is clear. When the oil light flickers, do not trust the dash sensor alone. Insist on a mechanical gauge test before driving another mile. Catching a pressure drop early saves an engine and a savings account from disaster. A subtle delay in shifting or a faint hesitation pulling away from a stop can be the only clues before a much bigger problem surfaces. In many Japanese vehicles, like the Toyota RAV4 and Lexus RX, the radiator and automatic transmission share a single integrated cooler. Over time, the brazed aluminum and steel joints inside that unit can develop hairline cracks, especially after years of thermal cycling and exposure to road salts. When that happens, coolant under pressure finds its way into the transmission fluid circuit. The result is a slow, almost invisible cross-contamination that turns the transmission fluid from clear red to a cloudy, pinkish milk. For owners, the first sign might be a slight slip or a delayed gear change. Checking the transmission dipstick reveals the truth. Milky or frothy fluid means coolant has invaded the automatic transmission fluid. At this point, the damage to clutch packs and internal seals may have already started. Transmission shops stress the importance of a fluid check at every oil change, especially after 80,000 miles, or if you notice even minor shifting issues. If contamination is caught early, replacing the radiator and flushing the transmission can cost between $300 and $1,200, a painful bill, but nothing compared to the $4,000 to $6,000 price tag for a full transmission rebuild. Technicians also recommend a pressure test on the radiator's integrated cooler circuit. If the circuit doesn't hold pressure or shows a slow drop, the internal seal has failed. Aftermarket external coolers can prevent recurrence, but the key is catching the problem before the fluid turns milky. For any owner, a quick glance at the automatic transmission fluid and a pressure test every couple of years can mean the difference between a routine service and a catastrophic transmission failure. A sharp clunk from the rear suspension at low speed can be the first and only warning before a much bigger problem unfolds. On models like the Subaru Forester, a single U-bolt holds the trailing arm to the chassis, anchoring the rear wheel's alignment. Over time, exposure to winter road salt or coastal humidity eats away at the bolt's protective coating. Corrosion sets in quietly from 40,000 to 60,000 miles in harsh climates. A small rust patch may go unnoticed during routine service, but the damage progresses beneath the surface. At 68,000 miles, one Forester owner heard a faint noise and replaced a worn bushing. But the real threat was the U-bolt itself. Within a month, it fractured clean through, letting the trailing arm swing out of place. The sudden shift stressed the driveshaft and rear differential, sending metal fragments into the oil and resulting in $3,600 in frame and drivetrain repairs. Shop records show similar failures often begin with a minor clunk, but end with major drivetrain damage if left unchecked. Technicians recommend a dynamic chassis scan at every major service, especially for vehicles in rust-prone areas. Verifying U-bolt torque to the factory spec of 95 Newton meters and checking for any sign of rust or distortion can prevent disaster. For owners, adding an underbody inspection every 15,000 kilometers is a small step that protects both the suspension and the engine's health. Ignoring odd noises from the undercarriage is a gamble, one that can turn a simple bolt swap into a multi-thousand-dollar repair. A rough idle and a persistent misfire code can sound like a simple spark plug problem, but on engines like the Mazda 6 Skyactiv G 2.5-liter engine, the story runs much deeper. In these engines, a cracked cam phaser or a clogged oil screen can throw the variable valve timing system out of sync. The result is not just a check engine light, it's a slow drift in camshaft phase that quietly sabotages combustion, fuel delivery, and even the catalytic converter. Owners often replace plugs or ignition coils, but the misfire returns, sometimes accompanied by a faint ticking or a loss of low-end power. Technicians who dig deeper use an oscilloscope to read the cam and crank sensor waveforms. On a healthy engine, the trace is smooth and predictable, but when the cam phaser starts to drift, the scope reveals a lag, sometimes just 15 to 30 milliseconds, that grows over time. This delay confuses the ECU, causing fuel trims to climb and idle quality to drop. An injector flow test often shows one or more injectors running rich, trying to compensate for the mistimed valve events. The real fix means opening up the timing cover and inspecting the actuator. If the phaser is cracked or the oil screen is clogged with carbon, oil flow drops and the actuator cannot hold position. Replacing the phaser and cleaning or swapping the oil screen restores timing control, but shop records show that waiting too long can scar the cam journals or even overheat the catalytic converter, pushing repair costs past $1,200. For owners, the lesson is clear. When a misfire will not go away, demand a scope test and a fuel system check before swapping more parts. Catching a drifting cam phaser early can mean the difference between a quick repair and a full engine rebuild. Today, a faint drip or a brief stumble at idle can signal thousands in hidden damage. In a market where even minor neglect turns into major expense, vigilance is your best defense. The next warning sign might be quiet, but the bill never is. Stay sharp and protect your investment.